Hello and welcome to another Pactober session. This is our third workshop in the series of 4. So first of all, happy Pactober. We've been celebrating 10 years of Pact. If you missed our big birthday batch, be sure to catch up on the Pactober playlist on YouTube, where you can see some absolutely awesome talks from Sam Newman, JB Rainsberger, and some of the Pact team and community. Cool. So introductions first. I'm Yousaf Nabi. I'm a community shepherd here at the Pact Open Source Project. I also work full-time at SmartBear, where I'm a developer advocate for Pact Flow, which were recently acquired by SmartBear. And I also work in the developer relations team at SmartBear. So I'm a man with many hats. This session is being recorded as well as being live streamed onto YouTube, so you'll be able to catch up with it later. And all the material that we're going through today will be made available, both the slides and the workshop content. So a bit of an agenda today. We'll talk about why the Pact plugin framework exists, why it came to be. We'll give a bit of an overview of what it is, how it works, and why you'll want to use it, hopefully. We'll give a demo. We'll do a couple of flavors of demos. So we'll do a slide-based demo, and then time dependent, we'll do code-based demo. We'll tell you how to get involved, and we'll do a Q&A. So there's some slides we'll have seen before in some of the other material, namely like Matt Fellow's strategy session and the plugin workshop introduction. I think that's also on YouTube as well, so you can check that out. So I won't dwell too much on some of these slides. So we'll just look at the kind of modern architecture estate and the challenges today, the challenges encountered by today's engineering leaders. So a quote that came from a large banking prospect for Pact Flow, which is the commercial kind of hosted broker. They were speaking to Matt, and they said they have a very large program with different Scrum teams, and it's a microservice-based, event-based architecture. And in there's a mix of RESTful, GraphQL APIs, and they're using message services, so AWS EventBridge or Kafka, and also a mix of third-party integrations. And testing that in this highly volatile set of integrated environments is really challenging, and they're looking to get better confidence. So they're all the kind of things that appeal to us, the being able to manage those integrated environments to give you better confidence prior to deploying into them, and to manage multiple services is something that Pact's very good at. So how can we expand that into this ever-expanding kind of range of technologies? And it's not just that customer saying it, it's being resonated from industry insights. So there's more microservices and there's more protocols to go with them. So lots of industry reports are coming out saying that 61% are saying that most of the API growth is coming from microservices, that 81% of companies are operating in a multi-protocol environment, and 57% are using 3 or more protocols. So Pact is very, very good at REST. It can provide message pact support, as we saw in our last workshop, where it just depends on the content, but we really want to be able to provide these guarantees over the protocols transport mechanisms as well. So additional insights: internal integration is the new focus. The challenges in integrating with these internal services are compounding the ability to deliver these quality systems, and it's paramount, even more paramount than integrating with the external services. And there's barriers to implementing microservices. So some teams can lack the experience or skills. There's a huge complexity in being able to design these systems, and it's sometimes not clear as to which approach to take. And there's ever increasing demands on the speed and delivery, and a limited time due to the workload that teams need to take on. So organizations, both small and mature, really are feeling the pain. And Gartner, who write great articles such as the Magic Quadrant, they've been saying that by 2025, less than 50% of enterprise APIs will be managed, and that's a scary it's a scary prospect when those APIs kind of run the world. So how can the Pact plugin framework kind of step in to afford some of those guarantees that we've provided in the past, but in this new emerging landscape? So we built the Pact plugin framework, and with some of the goals in mind when this was built, were to expand support to the widest range of use cases. So today we can support HTTP Pact and Message Pact, again agnostic of the transport protocol. But we want to be able to expand that support to whatever use cases you can think of. We want to really increase the time of market for these new features. So rather than waiting on a small maintainer team for a large user base, we want to provide the capabilities for users to extend the Pact framework for themselves. And by doing that, we hope that would grow the community, both in terms of users and contributors. By being able to directly contribute to the Pact framework from the outside, that might drive design changes or tweaks that you need to make to the core to make your experience better. You can check out the repo, github.com/Pact-Foundation/Pact-plugins. And that's where you'll find the examples that we'll hopefully be able to run through at the end of the presentation. If you look in the examples folder, you'll find a selection. There is a gRPC folder, a protobuf folder, and a CSV folder, and they show Pact being used in a number of different languages that support the Pact plugin framework. If you don't see a language covered, and it does cover the Pact plugin framework with the v4 specification, please feel free to submit pull requests. And if your language doesn't support it, we can help you build out a language. And you'll see in the next workshop how one might do so. So the general concepts with the plugins are you can create custom transport protocols. So rather than sending your messages via HTTP, you might use the gRPC transport mechanism and different content types. So rather than, for example, using the application JSON content type, you might use the application protobuf. There's the ability to use matching rules. Sorry, this slide slightly out of date. This came from the plugin launch. So there's the ability to use matching rules, and potentially you could build your own middleware or additional transports. There's potentially a numerous amount of applications. Not all of them may or may not be sensible or pragmatic. However, you know, the framework to build things is there, and users can do so as they see fit. Feel free to chat to anyone in the Slack community where they'd love to probably talk about it. Just to note, you can go on the Pact feature request board, so canny.pact.io or pact.canny.io, one of the two, and you'll be able to see a list of plugins that have been requested or delivered. There's been one community one delivered for Avro by a gentleman called Ali Uztek, so we're very grateful for that. It's awesome to see people using it in the wild and providing pull requests on it as well. So the general concept in the Pact files are subtly different to the general Pact framework that you know. So you can still use expressions and matching rules, So it has the concept of matches as per the Pact framework. However, they've been more generalized in order to work on arbitrary content types. So there's some primitive matching rules that you might be familiar with. So things like the equal to number, integer, decimal, etc. And then there's some other kind of meta matches, so not empty, each key and each value. You can see these particular matching rule definitions in the documentation on the Pact plugins repository, and they're also mirrored in the Pact website, docs.pact.io, although the ordering of them probably just needs to be cleaned up a bit. So if anyone's got some awesome skills on UI, please feel free to get in touch with us. And the concepts in terms of interaction types. So the Pact framework supports in v4 guys, but 3 types of interactions. So they are synchronous HTTP, and therefore types, use cases such as REST, SOAP, JSON RPC, or GraphQL. We have the idea of asynchronous messages, so Kafka, fire and forget, server push, and synchronous messages, such as gRPC protobufs, WebSockets, MQTT, data pipeline, or AWS Lambda. V4 Pact specification also allows you to combine interaction types into a single Pact file. And by combining these interaction types with the various plugin capabilities, that can allow very rich support for various frameworks, protocols, and use cases. Many of these are yet to be explored, so we'd love to hear your ideas and let you play around with them. So conceptually, kind of how it works, if we just take the maybe familiar diagram from anyone who's been on the docs.pact.io website, if we've got our consumer on the left and our provider on the right, so both the consumer and provider will execute tests in isolation of each other. So on the consumer side, it'd be using a unit testing framework. On the provider side, you might have to spin up your provider, but do that locally. And both of them communicate via their test frameworks with the Pact framework. So with the extension of the Pact plugin framework, all you need to think about is the Pact framework here in the middle will now communicate out to the Pact plugins. So that's a very simple kind of idea of how it kind of slots in. We'll stop for a moment for questions. We'll see if there are any. If there's not, we'll dive into a bit more of an explosion of that conceptual overview. No worries if there aren't any questions. If you are watching in the recap, feel free to join us in slack.pact.io. We can jump in the, I believe it's the Pact plugins channel. Feel free to just ask any questions. So we'll take a bit of a look at the conceptual framework of how the Pact plugins will work, and this will be kind of our order of the steps as we walk through, but we'll go through each one in detail. I just thought I'd put one kind of meta slide up that'll just show how we're going to walk through these, so it's always nice to know what's coming next. So first of all, you've got your code. It's the thing that you want to test. So you ideally are testing your own code and not just writing this with some other, not just writing this outside of your own kind of code base. This should be the actual kind of production code that you want to get confidence on. And you need a test framework. So the Pact core doesn't provide a framework itself. The Pact client libraries will work or should work within any test framework within your particular code's programming language. The Pact client library is then used. These would be something like Pact.js, Pact.jvm. There's also, these are available as command line applications. If you don't have a particular Pact implementation in a language you are using, it's also exposed in a FFI, so a C shared library that's compiled from a Rust code base, and that is what many of the Pact client libraries use in order to get the functionality. So that functionality that's contained in the Pact FFI in this Rust repository, which you can go to at github.com, pact-foundation /pact-reference. And if you check out the Rust folder in there, you can see the Pact reference Rust core. And some people might talk about a Pact core in Ruby. That was the kind of legacy core. And we talk about the native core or the Pact core in Rust. We're talking about this Rust folder in the Pact reference repository. So the shared core, that manages the lifecycle of a Pact test, and it provides key capabilities to the client libraries. So it'll expose a Pact mock server for a consumer to use and stand in for its provider during its unit tests, or it will provide a verifier, and this verifier on the provider side will provide the capabilities to retrieve a Pact file and replay it against a provider. The Pact core that's written in Rust over the Pact core that's written in Ruby, it allows us the use of additional Pact specifications, namely v3 and v4. The v4 specification supports Pact plugins, and these are supported through a plugin driver. You can see these plugin drivers, I believe, in the driver folder, possibly, in the Pact plugins repo. There are two drivers, one written in Rust for the client libraries which use the Pact FFI, and there's also one written in a JVM one that's written for the Pact JVM core, the Pact JVM repository, which uses its own implementation rather than using the Rust implementation. But either way, these shared cores, they have a plugin driver, and that plugin driver's job is to communicate with a Pact plugin. And this Pact plugin may be designed by the Pact core team, or it may be one that you design yourself. The Pact plugin driver and the Pact plugin communicate over gRPC, and they have a Pact plugin proto file that you can see, and it's a bit meta. The Pact Protobuf plugin tests the Pact framework with itself. So the plugin driver, it's responsible for discovering, starting, and orchestrating plugins. So in your Pact file, when you specify the particular transport and plugin you wish to use, the plugin driver will be responsible for finding that Pact plugin locally on your machine, or going and retrieving that plugin from GitHub. There's this idea of a Pact plugin registry that you can record your plugins or register your plugins to build up an open ecosystem. And you'll see later that the Pact plugin CLI will allow us to load these. So the Pact plugin driver, it will either discover these plugins on your local machine, or it potentially can reach out and retrieve these plugins at the time of test. So your plugin that you either create or you retrieve, it may communicate to and from your system under test. It may need to communicate with your system under test if it needs to deal with a new transport that the Pact framework doesn't understand. So for example, if you wanted to natively test the protocol of Kafka, your plugin would be responsible for being able to understand Kafka and therefore intercepting the messages between your system under test and being able to understand and communicate the data in that message between the expectations and the pact file. And this pact file itself now, as per the Pact v4 specification, now contains additional information. So this will contain information such as the required plugins in order to satisfy the interaction, those plugin transports, if there are additional transports required to satisfy that plugin. It may be that your plugin is just a matcher, so adds a new content type, or adds a new interaction type, but doesn't add a new transport. So it may be you have a particular content type that's native to you in HTTP, or it's not even something like Kafka. You'll be able to see in the Pact plugins repo, there's actually a CSV plugin, which is quite cool to check out. And the Pact file will contain, so the Pact file will contain the plugin name, the plugin transport, the interaction type of that plugin, and it will also contain the contents of, potentially contain the contents of any metadata associated with that particular plugin specification. So for example, if you're using protobufs, we will store the protobuf descriptor, so the proto file, in the actual Pact file itself. Plugin authors can choose to use custom markdown here, so that custom markdown can be used to be rendered in a Pact broker or in other tooling at later date. I believe the Pact broker doesn't support rendering content of v3 and v4 or this custom markdown. So anyone who is a bit familiar with Ruby, we would love that as a contribution, and it'd be absolutely epic if it came under Pactober, but no pressure. If you do manage to deliver it for us, we'll make sure that we get some Pact swag over to you. And then kind of maybe a little bit ancillary, there's a Pact Plugin CLI. So this is a helper utility that you can use to manage plugins. So these plugins will be stored on your local machine, and I, by default, will try and store them in your home folder in the .pact, in a .pact folder in your in your home.pact. This will be controllable by an environment variable called pact_plugin_dir, and that's all caps. The Pact Plugin CLI will allow you to discover the installed versions of your plugins and which names of the plugins are installed and their versions. It will also allow you to discover the available plugins that are in the plugin registry, and it will allow you to download and install plugins. So we'll show you a little bit later, there's some plugin documentation for creating your own plugin. There's a workshop. You'll be able to see it's when you publish your plugins, they'll be published to GitHub releases at the moment. And you'll just be able to provide a URL to the GitHub release to the Pact Plugin CLI, and you'll be able to get that plugin on your machine. However, it is a little bit ancillary now because the Pact plugin framework now has the capability to actually fetch out and retrieve these plugins at runtime. So you don't necessarily need to go and download these plugins beforehand. And then this is a bit of a meta overlay of all the different kind of components that we kind of spoke about. Cool. So I'll just leave that up for a moment. So we'll be able to pause on this when we do a recap. Just have a sip, check out if there's any questions. So let's take a look at a use case. So our use case is going to be on gRPC and protobufs. So unfortunately, these links are a bit poor, but I'll just say what they are. So we've got github.com/pact-foundation, and then we've got pact-plugins. And that particular repo is where you can find the examples for gRPC and protobufs in various different languages. I believe we've got examples in Go, Rust, JVM, both Maven and Gradle, and I've just recently added a gRPC one for JavaScript. And we also have the Pact protobuf plugin itself, which will be the actual plugin we'll be using to provide us the protobuf and gRPC transport and content type capabilities. That was actually designed by Ron during his work time at Pactflow. So this was one of the great ways at how SmartBear and Pactflow support the Pact ecosystem by building lots of tools in the ecosystem that are open source and freely available for you to use. They're all open source licensed and there for you to use, share, and improve. And the Pact plugin framework itself and the Pact framework itself is all MIT licensed. So this was one of the first plugins that was built. This repository link is github.com/pact-protobuf-plugin. And this is the actual plugin itself, so you can see all the code behind it that makes it work. It's written in Rust. If you're not familiar with Rust, we have a few other different plugin templates. So there's one in Golang. You can build them in any different language as long as it can provide a gRPC server and client. But there's various reasons we would say develop it in things like Rust or Go, basically things where you can self-compile it into a binary that's available in multiple platforms is really, really useful. That means that people don't need a particular and specific runtime on their machine. If you want to see more on how to build plugins in different languages, feel free to give us a shout on Slack, and I can help take you into some more kind of advanced demos. But we should probably talk about why gRPC and protobufs maybe a thing, or why they don't solve all the problems that people felt there were with HTTP, and why we still feel that contracts are important. So I don't know if we've got any viewers at the moment. But we'll just ask a question to anyone who is out there. Have you used protobufs or gRPC at the moment? Have you maybe tried it out just with a demo? I mean, there's some great samples on the Go, the gRPC getting started site, so I definitely recommend checking them out if you haven't already. Maybe you're using gRPC in production. If you are, maybe some of this reasons why might resonate with you. So we'll look at protobufs. So protobufs and things like Avro and Thrift are kind of ways of describing the messages that will pass through your system. And if you're familiar with HTTP and OpenAPI, maybe you can think about it like an OpenAPI document describes the operations and the messages, the capabilities that service can provide. Protobufs and Avro and Thrift kind of provide a description, the same kind of description of how the messages will flow between a system, and the clients and servers are traditionally generated from these descriptor files. And it aims, they have, because of this, they've got built-in versioning capabilities to support schema evolution in mind. So one of the big problems with HTTP was this idea of versioning, and it was quite hard to think of and design this extensible APIs up front. So if you can use a descriptive language that is designed with schema evolution in mind, then maybe that will solve some of those problems. And we have this other problem of, with extensibility, the idea of forwards and backwards compatibility. So again, these languages look to kind of solve the forwards and backwards compatibility problem. And they support this idea of code gen. So you can create really slick server and client SDKs in any of the languages that support these protobufs or Avro or Thrift. And in their own words, they say protocol buffers provide a language neutral, platform neutral, extensible mechanism for serializing structured data in a forward compatible and backward compatible way. It's like JSON, except it's smaller and faster, and it generates native language bindings. I mean, it sounds great, doesn't it? But it also became one of our most requested features on our open source product feature roadmap. So if it solves all these problems that people think exist in HTTP, that these languages were designed to solve, then why are people requesting the capability? And why have we built the plugin framework and this Pact protobuf plugin to support it? So there's this idea, colorless green ideas sleep furiously. So it's an absurd statement from a gentleman called Noam Chomsky, and it gives us a glimpse into the distinction between syntax and semantics. And this is something that was really well covered in the Pactober session on the 10th of October. So check it out on YouTube if you've not already. So syntactic well-formedness does not equal semantic well-formedness. So this particular sentence is grammatically and syntactically correct, but it carries no meaning. So being able to communicate is not enough. We need to be able to understand the semantics of the message. It's almost analogous to a HTTP message arriving to a server over TCP. And just because the bits made it there doesn't mean that the application layer could actually understand that message. So as that message comes into your application may or may not do things with that particular data. And this idea of a language which describes the entire message, it doesn't convey how the actual meaning behind it. So we could start with a motivating example. So say you have an order message that has a field price, and you have a consumer that reads these messages and tallies up the total for all these orders in a given time period. Now, if you remove that price from the message and you have this IDL and everyone can talk to each other, you generate new clients off new servers, and they say they're forwards and backwards compatible. So your programs can now still communicate. You don't get network exceptions in your logs, and your SRE team are really happy. You know, you've deployed these services and they're communicating, at least on a transport layer. But your application was really interested in that particular field that was held within that descriptor. And that's still a problem. Now, that might be solvable on a one-to-one relationship, but if you've got many different consumers of a particular protobuf descriptor that has, say, 8 fields in it, How do you know which users are using any particular fields at any one time? So when you decide to take a field out of that descriptor, how do you know who it impacts? So we found if you Google breaking change for protobuf or Avro or Thrift, you'll find that none of these particular major data serialization formats will solve this particular problem of how the application is actually using that message, not how just they're communicating over the wire. So Pact will, the Pact plugin framework and the Pact protobuf plugin will provide us the confidence to check that our system can communicate over the wire and also understand the particular usage of the message by our application in very particular scoped use cases. So we'll just rattle through some of these. So why it doesn't. So message semantics, the idea of optionals and defaults. We don't know who might be using any of these fields at any one time, and we can't really tell if a default changes, how that impacts the downstream system. How do we manage these breaking changes or provide that transport layer safety? And there can be very sometimes narrow type safety. So they're just very strict encodings and not necessarily kind of scope types for particular use cases. And that can lead to loss of visibility into real world client usage. And then lastly, we know with the Pact matrix and giving visibility into multiple consumers' usage of a particular provider, we've not seen alternatives or motivating, compelling alternatives to stop doing what we're doing. Why protobufs or Avro or Thrift solve this idea of being able to coordinate these changes. So how do we ensure that we can do forwards compatibility? And that might be using patterns such as the expanded contract, for example. So even here, we've got a quote here saying forwards and backwards compatible is not enforced. Forwards and backwards compatibility is a promise of the protobuf, but actually maintaining backwards compatible protobuf APIs isn't widely practiced. And it is hard to enforce. I'm not going to argue with that. It's very hard to enforce and maintain backwards compatibility with multiple consumers, regardless of the transport mechanism. That's why we think Pact is so great. So we take we remember our kind of conceptual overview, and we said that kind of Pact plugins just sit neatly into the Pact plugin Pact framework itself. We still have the same ingredients for a Pact test. So in this test, we're testing, in this particular case, we're testing the out-of-the-box root guide project. So if you go on to the gRPC website, they've got really great quick starts in lots of different languages, actually every single language that gRPC supports. And you'll see on there, some of the languages don't support server and client gRPC capabilities, that they can still be used with the Pact protobuf plugin as either a consumer or a provider. If you want to build a Pact plugin framework in that language, if you're on that gRPC website, your particular Pact, the gRPC, the language that you choose, it needs to be able to be a gRPC client and a gRPC server. Actually, that might be wrong. It might just need to be a server. Check back with me in the Pact plugin Slack. So we're going to test the out-of-the-box root guide project. So you could go on to that gRPC website, go onto the quick start, go onto any particular language, and you can check out this particular proto file descriptor. So you give this particular get feature a point, and the point has two fields. It has a latitude and a longitude, and then it will return back the closest feature to that latitude and longitude. So if we look at our Pact test, it looks very similar ish to a Pact test that you have seen before, if you're familiar with the HTTP framework. One of the subtle differences you might see is our is this gRPC interaction. That's a kind of big JSON string here. It has to be a JSON string when you pass in this gRPC interaction to the with contents. However, you could use this as a JSON object and then just stringify it when you pass it into the with contents. So within the interaction block, there will be some request and response expectations, and they will be defined in a format that is particular to your plugin. So in your Pact framework, once you have your Pact framework, that's indicated by this P here in Golang, you'll add a message type. So this particular type of interaction type, we said there was a synchronous HTTP, there was asynchronous and a synchronous message type. So in this particular example, we are going to test a synchronous message. So we'll call that in our framework, we'll pass in a name, we'll use our given. So this will be our preconditions. So we need to ensure that the particular feature that we expect exists. Our feature is big tree. And we need to set up our Pact contents. So here we have our particular Pact contents, and these are defined in a specification as per our Pact plugin. This looks somewhat similar to the Pact message interaction. So because this is a synchronous message, it has a request and a response. So in our request, we're going to send the keys latitude and longitude, and we're going to expect a response that has a name and the location value that will match up with that latitude and longitude. And because we don't want to set up fixed, we want to test the shape of this message, and we want to check the shape or the schema of this message, but we don't necessarily want to fix our provider into needing to provide us the exact values. We use matching rules. So we have the idea of serializing our matching rules, which need to be a string. So here we have a string denoting the matcher type. So here we say matching, and then our particular matching type. So our matching type is number here, and it could be string, decimal, etc. And then our particular example value. So the example value can be rendered in your Pact contents when you provide a concrete example, but this will allow our provider, when we verify it, to ensure that they provide that they expect a request with the, well, if we look at the response, make sure that they return a name, and the name can have any value in it as long as it is a string. The string doesn't particularly have to be a tree. And those matching rules allow that flexibility between your consumer and provider verifications. The state allows us to set up the particular state in order to satisfy the request and response. And then you'll start the particular plugin transport once you set up your interaction contents, and then you'll be able to execute your test. When you execute your test, you'll be able to call your particular system under test. So here is the get feature function, and we pass in the particular port. This port was provided to us by the Pact framework. So behind the scenes, when we start this transport, we haven't provided a particular port for our provider to for our protobuf plugin to start up on. So our Pact protobuf plugin will start up on a random port, and our Pact client library will be responsible for providing that port and making it available to our tests. This will allow our system under test to retrieve the particular port that our mock provider is running on in order to direct the request to the Pact framework, so that the Pact framework can intercept it and verify that the interactions match up. Verify that the particular correct request was issued. So the request we said here was we'd make a request with latitude and longitude, and it would have a particular content type of application protobuf. So as long as our client made that request, our mock provider provided by the protobuf plugin will return this response name with the value big tree, and will return location and latitude with the number 180 and the number 200. This will allow our get feature to then do its business logic with that response and return back the thing. So in this case, it's a feature, and then we can perform our regular unit test assertions based on the values returned from this get feature function. So here we have made sure, or the Pact framework will make sure, that we issued the right request, that our system under test issued the right request, and then our unit testing framework will allow us to ensure that we, based on a particular provider response, so in this case, a feature big tree exists, that we actually get whatever business value we want to out of the response of get feature. So this will allow us to really quickly unit test our gRPC consumer in isolation, but generate a Pact file off the back of it. And that Pact file will then be able to be shared with our provider and allow our provider to work in isolation, and therefore we don't have to wait till we both deploy these to know that they'll be able to talk to each other. So on the provider side, the provider looks very similar to a consumer test that you, on the provider side, it looks somewhat similar to a existing Pact verification test. So in the Pact, in your Pact verification test, the first thing you'll want to do is start your provider. Your provider will need to be running because we're going to issue the requests that were in the Pact file against this particular provider. And with the Pact provider framework, you will instantiate a verifier function. And here we are going to set up a plugin verifier. With this plugin verifier, Pact verifiers have the idea of transports. So we have the idea of a regular HTTP transport, or there could be particular transports that are generated by your particular plugin. So in Pact Go, there's just a nice little wrapper function that provides a plugin verifier. The slight details may differ in your particular client language, but you'll get your verifier, Pact verifier. You will add in the capabilities to enable it to describe a plugin or use a plugin. So this will be basically enabling like the V4 interface. And you will say, we're going to here verify a plugin request. We're going to tell the provider, we're going to tell the Pact framework where this provider is running. So when we start this particular provider, if we don't provide a port, or in this case, it will just default to a particular port. When this start provider function is called, it will start as a new gRPC server. This gRPC server will be registered with our particular protobuf, and this particular protobuf is our root guide server. So this is basically the simplest code that's basically auto-generated from the from our protobuf descriptors that enable us to respond to requests. So I'm going to start that provider, and it's going to be running on localhost port 8222. If you have a different port, you might want to return that port from your start provider function so that you can pass in that particular port to your Pact verifier framework. So here we tell it which port our provider is running on. We provide it the name of our gRPC provider. We pass it the name of our provider, which in this case is gRPC provider. And then we tell the Pact framework where our Pacts live. Now, this could either be on your local system, or it could be retrieved from a Pact broker. So here we're using the Pact files, but otherwise you might use the Pact broker capabilities either via a Pact URL or via Pact consumer version selectors, depending on your verification mode. So you start your provider, you call the Pact plugin framework, and then you provide your set up your Pact verification options. You execute it, and you will get some output. So here we see we're verifying a Pact between a gRPC and consumer, and everything went okay. What happens if it fails? So if our consumer, if our provider, for example, was returning a different value or wasn't able to return a value, we would see here you get the same kind of rich failure data. So you see that we've been verifying a Pact, but it failed, and we can see the particular, we were expecting a matching body. We can see the particular keys that were set out in the expectations from the consumer side. So from name, we expected a string. For latitude, we expected a number, and that number should be equal to 180, or we would have the matcher applied to it. In this case, there was just no response being returned. The Pact framework itself didn't actually do this verification. The Pact protobuf plugin will take care of looking at the Pact content and the matches and telling the Pact framework whether the verification was a success or a failure. It will also provide the metadata for the particular failure details. You can look at the Pact plugin logs. So there'll be Pact plugin logs generated in your home.pact folder or wherever you have set your Pact plugin dir, and you'll be able to look in the particular Pact plugin name version in a logs folder, and you should see a particular log file. Probably have far too much information in there to be really nicely readable, but all the information emitted by your Pact plugin should be there. So we can just see those failures highlighted. So demo-wise, we've got 6 minutes, so I will definitely show you it run on the machine, but we'll just go through the rest of the slides first. So how can you get involved? If you are wanting to test out gRPC, you want to create a plugin. If you want to create a plugin, either on your own or with a friend or a client, it says join the workshop, but actually I'm going to share with you in the next slide. You can try out the Create a Plugin Pact University course. You can just try out the Pact plugin framework, So you can drop into the Pact Plugins repo, you can go into the examples folder, and you can see a selection of gRPC, protobuf, and CSV examples in a few different languages. Please try them out, talk about it, vlog about it, vlog, provide feedback in GitHub issues, provide enhancements, provide examples, whatever you want to do. Please amplify the message to your networks. We'd love for you to be able to share it with your social channels. So if you're actually interested in building a plugin yourself, and you don't just want to just try out one we've already made, or you don't really want to try out gRPC, you can check out the docs.pact.io website. If you go to the university section, and then go to create a plugin, either in the, you'll see a table if you go to the university, or you can go to the sidebar, you can check out create a plugin. You will be able to understand the basics of the Pact plugin framework. You'll be able to understand the basics of plugins by creating a simple content matcher plugin. So we're not going to worry about the transport mechanism at all. We're just going to look at the content type. You'll be able to publish the Pact plugin to GitHub, and that can be used by others. And you'll also be able to use that particular plugin in a project. And you can either run it from your local machine, or you can run it in a killer coder example, which is kind of a 60-minute online session with an integrated IDE and kind of virtual machine. I probably recommend doing it on your local machine, just because any changes you make in the killer code environment aren't preserved. So what's in it for you? Be on the bleeding edge. I still don't see huge amounts of stuff posted, like examples around gRPC and stuff in various different languages, or really well tested stuff. So I would love to see more examples out there in the wild, and it'd be even greater if they were using Pact as well. Get in touch if you want to build something, definitely help out. There's loads of benefits in participating in an open source project. You get to contribute to the future state of the leading contract testing framework. You can join our weekly maintainer meets, and they get shown on YouTube if we remember to record them, which we should do. And you can build your own profile and get some swag. Sorry, this slide is slightly out of date. That's okay. Right, cool. So thank you very much. If you are watching this live, or if you're catching it up on the recap, feel free to get in touch, join our Slack community on slack.pact.io. Feel free to say hello in the Pact plugins channel, and let's see if we can run some demos. We've got 2 minutes. So I'm in the Pact plugins repository. So I've just cloned this down. So in here, we've got our, so we mentioned about the Pact plugin drivers. So there's 2 Pact plugin drivers. They're written in JVM and Rust. We've got particular Pact plugins. So there was the early protobuf Pact. There's an early version of the protobuf plugin. The actual full one is in the Pact Flow Pact protobuf plugin repo. And there is the very alpha CSV plugin that actually lives in this repository still. So this protobuf one can be looked at as an archived example, but might be just useful if you just want to see how a plugin works. And then there's a particular proto file. So this proto file is the plugin descriptor for the Pact plugins themselves. So this is the particular proto file that the Pact plugin framework and the Pact plugins use to communicate with each other. So just if you want to see how they work, you can take a look at that. But anyway, we're going to take a look at our examples folder. So in our examples folder, just make this slightly bigger. So in our examples folder, there is a CSV folder, a gRPC folder, and a protobufs folder. In the CSV folder, you can see there are consumer and provider examples. So there's a JVM and a Rust one. In the protobuf example, there is an area calculator example. There's a plain protobuf consumer example in JVM, Maven, and Rust, and a protobuf provider that will support them. And then there is a gRPC folder, which has some various different examples in them. So the particular one that I'm going to look at today is the gRPC area calculator. And in here, you will find a master proto. So it's this area calculator proto file. You'll also find various different examples. So from the consumer side, there is a consumer written in Go, a consumer written in JVM, consumer written in Maven, consumer written in Rust, and a consumer written in JavaScript. There is at least a Pact test in each of these. Some of them have consumer implementations. If for one of these, they don't have a, they all have consumer implementations, consumer Pact tests. They may not all have consumer implementations, as in some of them, the gRPC server is kind of just stood up in the test. And then on the provider side, there similar, there is provider tests for Go, JavaScript, JVM, Maven. Yeah, correct. There is one for Go, JavaScript, JVM, and Maven. So let's take a look at our consumer in Go. So in our area calculator proto, we have a calculator service. So this calculator service exposes two functions, a calculator one and a calculate multi. There's a shape message, and this shape message could be one of any 5 types. And each of those 5 types of messages has a potential different shape. So this is maybe somewhat complex, bit more of a complex example. So the particular message based on the consumer could be any one of 5 particular shapes. So there may be a particular consumer that only deals with one shape, for example. And then we can take a look at our consumer.go. So our consumer.go will, it has a main function. That main function will call a get rectangle and square area. That get rectangle and square area will call and set up a gRPC client. That gRPC client will then call one of the exposed methods in that gRPC, in that proto message. So here it will call a shape message with a rectangle and a square, and it will pass both of those shapes to the calculate multi function. It'll expect to get a result and pass that back. So in our consumer test, we have, let's see if we can try and make this a little bit bigger. So in our consumer test, we will need our Pact framework. So because this is Golang, we have our Pact Go. We set up a new synchronous pact. And in this new synchronous pact, we tell it the consumer and provider that this pact is for. We will tell the Pact framework where our proto file lives. And then we can set up our gRPC interaction. So these are all the particular expectations that we require for our test. So we're going to make a request with the shapes array. We're going to send a rectangle and a square. We've got some matching rules applied to them. We've got response. And then we can see, as per our example in the presentation, we've got a mock provider. We tell it that we're using the Pact plugin. We're going to set up our contents that we set up earlier that we're going to pass into this with contents. We're going to start the transport. So this is a particular gRPC transport. And we're going to tell it which host that the mock provider will run on. And then we'll call our particular function. And then again, we'll do our unit testing expectations. So there's a make file in this repo, and this make file just shows the different commands that you can use in any of the particular repos to build any of these. When you run the go test, we'll see here that our Pact test was successful. Mock serve was running. We calculated a mock rectangle and square request. We determined if there was mismatches, there wasn't any, so we wrote a message pact to this location. And if we take a look at that message pact, which is in this pact folder, we can see that we've got our consumer, we've got the interactions, we've got a particular bit of interaction markup. So this is the particular message, and we have some details around the protobuf descriptor, so which was the actual method we were calling, and what are the request and response contents and the matching rules contained within them. You can also see, if we scroll down to the bottom, we have this proto descriptors and proto file. So that is a base64 encoded description of the proto file. And then we also have a stringified representation of it. So that was running our consumer test. If we run our provider test is currently set up to test against our pact file that is written. Wait one moment. We have our provider test here. So in our provider test, we import our Pact provider framework. We set up our verifier. We tell it where our provider is running. We will tell it the particular transport type. So here it's gRPC and it's running on port 8222. We tell it the name of the provider and where that Pact file lives. And then, as before, we have a function, helper function, that will start up our provider. And just before we instantiate our test, we will start that provider. And then we'll call our verifier, and we will assert that it runs correctly. So here we can see that it failed. If, for example, we were to start our provider on a different port, we should see that this test fails. So, yeah, correctly, we have a failure, and this particular failure failed because there was a transport error, and that indicates an error with the provider API. Because and if we were to look into the Pact plugin logs, which are in Pact plugins, Pactober 36 logs. Let's see, there's a few logs here, and we'll just clear that terminal. So we can see all the different logs that were spat out by the Pact plugin framework. And you can see here there was a received error response for a transport error. It failed to connect with a connector refused. And then you can start digging into the particular details here, or look at your service logs to work out why. But obviously in this case, we just found out that we changed port that we expected it to be running on, so the server wasn't running, and we got that correctly, a TCP connect error. So that's it. I'm glad the demo gods were with us. We're slightly over time with 8 minutes. Please feel free to jump into this repo, and you can check out some of the different examples. I will just run a JavaScript one as well, just to show that that works. So in the JavaScript Pact.js, you'll need to use the latest version. You'll also need to have, it's currently as a beta, the v4 capability. So you'll need to have a feature flag set, enable feature v4 set to true. So here we can see we've got the same implementation or an area calculator, but written in Pact JavaScript, and this has generated a Pact file. And if we now test that, because there's also a provider implementation, we can see that that's able to verify that shape message correctly. And because all of these they all work on the same area calculator. They should, in theory, be able to verify each other's pact. So any of these area calculators in a particular language should, in theory, be able to be serviced by any of the providers in any of the languages. But it's a really nice way to show the cross-platform capabilities of Pact. So I'm going to wrap up now and say thank you again. It was really good that we actually got to show the last little bit of the demo. So yeah, please feel free to check out these demos, get in touch, join the community and say hi. Brilliant. Thank you for your time, everyone.